Hello and welcome to the NPTEL MOOCs course on Foundation for Virtual and Augmented Reality Systems. We are currently in lecture number 7 where we are discussing VR hardware. We will continue our discussion on VR hardware in this part of the lecture. So, previously we talked about a systemic view of the VR hardware, namely different components and their relationship. We also talked about broad categories of VR hardware, namely the input, computer and output. Then we discussed about the hand based input and we started our discussion on the non-hand input. We are going to continue our discussion on non-hand input and also we are going to talk about the processor and the output part in this lecture. So, under non-hand input we have earlier seen two categories, head input and eye tracking based input. There are other non-hand input methods, input devices as well. One of such categories are the full body tracking. So, here the devices are there to track more than just the head and hands. So, earlier we tracked some parts of the body, head, hands and eye. In full body tracking we track more than that. It adds to the illusion of self embodiment as well as social presence. So, since we are tracking full body, the input tracks the full body movement. So, the output that can be generated based on that input can give the user a feeling of self embodiment in the virtual world as well as social presence in the virtual world, because the user gets to see a fuller representation of himself or herself. Now, there can be multiple approaches to get the input from the full body. Broadly, there are two such approaches. One is using a motion capture suit, in short it is called mocap. Now, typically such suits come with various sensors within the suit. An example is shown here in this accompanying figure. This is the perception neuron suit. It contains a network of straps with IMU or inertial measurement unit sensors. These are the straps, as you can see here, worn at different parts of the body, leg, hand, arms, even head, everywhere you can see. And when the body movement happens, these sensors captures and transmits raw movement data, which then are combined and converted to full body position and movement. Another approach is using camera based tracking. The one such possible setup is shown here in this entire figure. As you can see, there are multiple cameras, camera number 1, 2, 3, 4, 5, 6, 7, 8. So, these are surrounding cameras. In between the cameras, one actor is there. The actor typically wears a suit with some fiducial markers. As you can see here, the cameras can detect the movement of the markers and based on that can infer the overall body movement of the character. So, typically reflective markers are used and there are multiple cameras. An example of such system is OptiTrack, or even Microsoft Kinect can be considered to be example of such camera based full body tracking system. So, there are broadly two approaches for full body tracking, mocap and camera based tracking. Then category 4 refers to voice or speech or sound tracking. So, it captures through this type of input devices, we can capture voice, speech, non-speech sound as input for interaction in the virtual world. For that, what we need to use, what are the devices, input devices, microphones, simple microphones or microphone arrays, that is set of microphones to capture sound in a 360-degree environment. So, those are 4 categories are basically non-hand input techniques, namely the head tracking, eye tracking, full body tracking and sound based tracking. So, we have covered the input part, hand based and non hand based. Let us shift our focus to the processing part, that is the computer. Computers are, in our context, computers are devices that process the data that are coming from the input sensors, and then based on that processing it activates or actuates the output devices. Now, the processing elements or computers are selected according to the requirement. For example, depending on application or user or input output devices, availability of input output devices or the level of immersion required, we can choose the corresponding processing element. Sometimes it need to be very high configuration, sometimes it can be regular configuration. So, we can have a standard PC as a processing element or a computer in our VR system setup, or we can go for high end workstations having high quality GPU as part of the processing element of our VR system, or we can have a distributed computer system interconnected through high speed communication network as part of our processing component, or even we can use our smartphone for doing the processing. So, the range of processing elements can be used, which depends on the kind of application we are trying to develop, the kind of users we are targeting, the kind of input and output devices we are assuming, and the kind of immersive experience we plan to provide. Now, when we talk of processing element or the computers, the major 3 components that comes into mind are the GPU, CPU and RAM. We all know the terms. So, when we talk of GPU or graphics processor unit, multi GPU enabled systems are typically used for building VR applications, and for rendering also we prefer to have good quality GPU enabled graphics card. GPU stands for graphics processing units. For those who may not be aware, these are typically used to speed up rendering process because of their inherent parallel processing abilities and the inherent parallelism in the rendering process. So, later on we will take up this issue in more details in another part of the course, where we will talk about computer graphics, the rendering process and how GPUs are suitable for such a process. For the time being, it is sufficient to know that GPUs are very useful in rendering complex graphics, complex scenes that are typically part of realistic VR experience. So, GPU enabled environments are preferable. Even modern day CPUs are also quite powerful. However, CPUs have many other tasks to do. So, if we solely depend on CPU based systems where GPU is minimal, GPU support is minimal, then there can be a performance issue. However, multi-core processors can greatly increase computational capacity and can support in a better way as compared to non-multi-core or unicore processors. But nowadays, of course, by default all processors are multi-core, so they are quite powerful. However, GPU support is preferable. On the RAM or part, each XR engine has its own minimum RAM requirement. What is XR engine we will cover in a subsequent lecture. It is basically a middleware that are required to support and render to develop VR experience as well as render the experience. Now, each such engine has its own requirements. Typically, at least 8 GB of RAM is preferable to have in your VR system hardware part to have a good user experience. So, that is in brief about the processing elements. We just covered the basic ideas. Then let us move to the output devices. What kind of output devices that are typically used to render VR experience? There can be several categories of output devices, starting with the visual display, then we have audio output, then we have haptics, then motion platforms and treadmills, and some other sensory outputs. That means the outputs are meant to stimulate other sensory organs such as taste and smell sensory organs, namely the tongue and nose, but these are quite premature systems, not widely used or widely available or even popular. So, we will skip any discussion on these type of systems. They are still confined mostly to highly specialized environment or research domain. So, we will mostly focus on visual displays, audio output, haptics and motion platforms and treadmill. Let us start with the visual displays. Now, when we talk of visual displays, these are essentially displays meant to stimulate our visual sense, that is our eyes. So, there can be three broad types of visual displays. First category is head mounted displays or HMDs, which are wearable and mobile. Then we have wall fixed displays, which are not wearable, they are stationary. And finally, regular displays, which are mobile or can be stationary. So, we have HMDs, wall fixed displays and regular displays. Let us talk about HMDs. So, these are common metaphor for VR. Whenever we say or use the term VR, essentially we refer to, or it comes to our mind that somebody is wearing such a headset and experiencing something. So, a very common metaphor. Earlier we have seen that HMDs can be used as input to track head motion, but its primary use is as a display device. So, it is a sophisticated equipment. It integrates electronic, optical, mechanical and even audio components within this package. It places images directly in front of users' eyes using either one or two small screens. So, when it is using one screen, that is for monoscopic viewing, when it is using two screens, that is for stereoscopic viewing. So, of course, HMDs with stereoscopic viewing is more common as compared to HMDs with monoscopic viewing. Now, HMDs themselves can further be categorized. Three categories of HMDs can be there. One is non see-through, one is optical see-through and the third one is video see-through. Non see-through type of HMDs are typically used in VR. Optical see-throughs are HMDs that are typically used in AR, whereas the third category, that is video see-through, are typically used in augmented virtuality. That is, we are experiencing an artificial or virtual environment within which some real world images or videos are appearing on real time basis. So, that is augmented virtuality. Recollect our discussion on it in our earlier lectures, the first and second lectures. Now, we have video see-through HMDs that support augmented virtuality. So, that is about HMD. Then we have a second category of display, that is walled fixed display. It renders graphics onto surfaces that do not move with head. So, we have a display surface or display screen which is fixed, do not move with head. The displays range from standard monitor to displays that completely surround the user, which is typically called cave. One early example of such a walled fixed display used for VR is the fish tank display, developed way back in 1993. It is described as a stereo image of a 3D scene viewed on a monitor, fixed monitor, cannot be moved, using a perspective projection coupled to the head position of the observer. The setup is shown here. There is a tracker which tracks the head position. This is the monitor which is fixed, it cannot move around, and then there are haptic devices that are input part. So, let us skip that part. So, when the user moves the head, the content on the monitor changes, it shows a perspective view of the content, which is typically what we get to see in real world, and the head position is tracked using the tracker. So, with the movement of head, the view changes and the user gets the sense of being there. It contains CRT monitor, haptic device, optical tracker, the latter two are input part, whereas the monitor is the output part, which is the walled fixed display. The more latest walled fixed display example is the surround screen displays, which are typically known as cave systems. Typically, they have 3 to 6 large screens, puts user in a room for visual immersion. So, user is surrounded by screens. Such system is usually driven by a single or group of powerful graphics engines and requires elaborate tracking of the user's movements. So, that is another example of walled fixed display. Here the display is not moving, rather the user can move within a physical space. The third and final category are the regular displays. They refer to the regular tab or smartphones that we have. They are mobile, of course, nothing specialized are there. Typically, they are relevant for non-immersive VR and mostly used for augmented reality or AR. So, that is about the most prevalent form of display, that is head mounted display. There are other output devices as well. Let us talk about those. Audio output is another part of the output devices that are typically used in VR setup. We can have spatialized audio that can provide a sense of where sounds are coming from in 3D space. Speakers can be fixed in space or move with the head to get that spatialized feeling. Headphones are preferred for a fully immersive system where with the movement anyway the sound source can change with the head movement, and accordingly we can get the spatialized feeling. Then we have haptic rendering systems or systems that activates our touch sensation. Now, haptics are outputs exploring our touch perception, and it can be categorized in different ways. The type of haptic outputs that we can use can be categorized in different ways. We can have passive versus active devices. We can have tactile versus proprioceptive devices. We can have self grounded versus world grounded devices. So, passive devices are static physical objects, whereas active devices are physical feedback controlled by the computer. Tactile are touch sensation obtained through skin. So, our skin gets activated, whereas proprioceptive forces are activated forces are those that activate our joints or muscles. Self grounded means the devices are owned on the body, whereas world grounded means they are attached to the real world, they cannot be moved around. So, when we talk of passive haptics, we are referring to real world physical objects that are matching the shape of the virtual object. So, when we touch those real world objects, we get a feel of interacting with the virtual objects. But those real world physical objects are not controlled by the computer, whereas in case of active haptics, we have objects, physical objects that are controlled by computers, which gives us a sense of touch when we are dealing with virtual objects. So, these are more common form of haptics used in VR experiences. When we talk of tactile haptics, they are basically devices that provide sense of touch through the skin. It can be of two types, vibrotactile stimulation and electrotactile stimulation. In case of vibrotactile stimulation, we are using mechanical vibration of the skin, whereas in case of electrotactile stimulation, we are using electrode that passes current through the skin. As opposed to that, we can have proprioceptive force based haptics, which provides a sense of limb movement and muscular resistance by providing corresponding signals to the muscles and joints. Then we have self grounded versus world grounded devices. So, in self grounded devices, as shown in this accompanying figure, we can see that these are owned or held by and move with the user. Handheld controllers are examples of such devices, whereas in case of world grounded haptic devices, as can be seen in this figure, accompanying figure, the device is physically attached to the real world and can provide a true sense of fully solid objects that do not move. So, in case of self grounded, it is worn and movable. In case of world grounded, it is not movable. Another type of output devices are motion platforms. These are hardware devices that moves entire body, resulting in a sense of physical motion and gravity. It conveys sense of orientation, vibration, acceleration and jerks. However, use of such platforms may result in motion sickness, which can be reduced by decreasing conflict between visual motion and the perceived motion in the real world. So, these such motion platforms can be of two types: active motion platform. These are controlled by computer simulation as shown here. So, computer controls the platform, whereas there can be passive motion platform which are controlled by the user. There is no direct computer control here. Passive platforms are likely to result in lesser motion sickness as compared to active platforms. Also, there can be treadmills, another type of output device. It provides a sense of one is walking or running while actually staying in one place by providing different sorts of input to the feet or leg. We can have omnidirectional treadmills. These are quite common in virtual reality systems, which can be of two types: active, that means it is being controlled by a computer. So, computer controlled mechanically moving parts are there, which gives us a sensation of walking or moving, whereas there can be passive also, like motion platforms. It contains no computer controlled mechanically moving parts. So, user has to control it himself or herself. So, with that we have come to the end of this lecture. Let us quickly summarize what we have learned. So, we have talked about different hardware devices used to generate VR experience, which included broadly three categories of devices: input, computer and output. Input we have seen can be handheld input or non-handheld input, whereas output can be visual, can be auditory, can be touch or haptics, can be motion platforms or proprioceptive forces. In our next lecture, we will cover the hardware that are used for AR experience, augmented reality experience. I hope you have understood the concepts, you have got an overview of the overall hardware that are used as part of the VR system, even the overall idea of a VR system as such. So, I have used few references to make this content. These are listed here. If you are interested, you can go through the references for more details. So, thank you. Looking forward to meet you in the next lecture. Happy learning.